Question 10A. Copy and complete the table of value for the relation y equal to minus s squared plus s plus 2 for minus 3 less than equal to s less than equal to 3. You have the table of values with some missing values for y, and of course you are expected to solve for them. Be part of the question using scales of 2 cm to 1 unit on the x-axis and 2 cm to 2 units on the y-axis. Draw the graph of the relation y equal to minus s squared plus s plus 2 over the range of values of s. See part of the question. From the graph, find the figure 1 minimum value of y. Figure 2 roots of the equation s squared minus s minus 2 equal to 0. Figure 3 gradient of the curve at s equal to minus 0.5. Solution. A part of the question is to copy and complete the table of values. Already the values of s are known. For us to get y values, you need to get minus s squared. Of course, s values remain the same for this. Plus 2 is a constant which is written under each value of s. So you start with minus s squared. Now this is what happens. If you square minus 3, you have 9. Then 9 times minus becomes minus 9. So you square before the minus sign multiply. If you square minus 2, you have 4 times minus, you have minus 4, and so on. The value for this s remain the same for this. Now 2 is a constant. You write it under each value of s, as you can see clearly. So you have to add here to get the first y value. Minus 9 minus 3 is minus 12 plus 2. You have minus 10. If you come here, minus 4 minus 2 is minus 6 plus 2. You have minus 4, and so on. B part of the question is to plot the graph. Let us restate the given scales: 2 cm to 1 unit on x-axis, 2 cm to 2 units on y-axis. This graph I'm using, each box or square contains 5 lines. By default, each box is 1 cm. 1 cm. So by the given scale on x-axis, you need to combine two boxes from the origin to the end of the second box. You give it 1 unit. The next 2 becomes 2. The next 2 becomes 3, and so on. If you move to the left, you have minus 1, minus 2, and so on. Now on the y-axis, the same 2 boxes is 2 units. So you combine 2 boxes, you give it 2. The next one is 4. When you move down, you have minus 2, minus 4, minus 6, and so on. Now this graph is like this because for you to draw the x-axis, you need to look at y values. The y values, you have more negative than positive. For that, you don't draw the x-axis at the middle. You have to shift your hand up, thereby giving more space to the negative y values. That is the reason. All right. Next thing is to plot the first set of points when x is minus 3, y is minus 10. This is minus 3 for x, minus 10 for y. This is the meeting point. Minus 2, minus 4, somewhere here. Minus 1, 0. When x is minus 1, y is 0. You plot that point directly on the x-axis. When x is 0, y is 2. This is where I am now. So you also plot that point directly on the y-axis. When x is 0, y is 2. The next point 1 and 2. When x is 1, y is 2. When x is 2, y is 0 on the x-axis. When x is 3, y is minus 4. Next thing is to join all the points together. Don't forget, you always add the title of the graph, and it is simply the equation you are given to plot. All the points have been joined together. We move to C part. Roman figure 1, the minimum value of y. Now, anytime you plot a quadratic curve, you always have two shapes. You have the U shape and the N shape. The N shape, as you can see from this question, you can obtain maximum value from the N shape and you obtain minimum value from the U shape. This curve is N shape. For that, the graph has no minimum value. Roman figure 2, roots of the equation x squared minus s minus 2 equal to 0. Now, the graph you plotted is this. You can only solve this equation using this graph if you can simplify this given equation to exactly this. To achieve that, multiply through by minus 1. So you have this result. Now, the right hand side is 0. If you replace the left hand side with y, because this equation is equal to y, the roots of the equation occur at y equal to 0. That is the point of contact of the curve with the x-axis. At that point, y is 0. And you have minus 1 or 2 as the root of the equation. Roman figure 3 of part C. Gradient of the curve at s equal to minus 0.5. By the scale you are using, one line is equal to 0.1 on the x-axis. So this point is minus 0.5. You trace it to the curve and you draw a tangent. You draw the tangent to any length of your choice, but not outside the graph. After drawing the tangent, you can form a triangle from it. So from this point to this part is 1 point. That is when s is minus 3, y is minus 4. That is what you have here. From this point, if you trace to x-axis, you have 0.8. If you trace to y-axis, you have 4. So we take this as the first point, that is s1, y1. This as the second point, s2, y2. You insert there in the gradient formula. When you simplify, you have this result. After division, you have approximately 2.1 as the gradient at s equal to minus 0.5. The beauty of this is that if you extend this your line from where I stop further and read the points accurately, your gradient will be the same as the one obtained by the voice of Peter Course.